Hello everyone. We have a motion problem here and it reads a bus traveling at a constant speed of 50 meters per second along a straight road passes a stationary taxi cab. The cab begins to move 8 seconds later with a uniform acceleration of 3 meters per second squared in the same direction as the bus. Calculate the time taken by the cab to catch up with the bus. Calculate the distance the cab had traveled to catch up with the bus. Calculate the velocity of the cab when it catches up with the bus. So what we understand from this problem is we have a bus that is moving at a constant speed and it passes a stationary taxi cab. So after passing the taxi cab, after 8 seconds later, the taxi cab begins to move in the same direction as that of the bus. It is asking us the time taken by the cab to catch up, that is to meet with the bus. The second question is asking us to calculate the distance the cab had traveled to catch up with the bus. The third question is asking us to calculate the velocity of the cab when it catches up with the bus. So let us first try to represent this diagrammatically to facilitate our understanding. So let's say this is the bus, okay, and it is moving at a velocity of 50 meters per second. So let's say this is the point where we have the stationary cab. It means the initial velocity is 0 meters per second. So the taxi cab is at rest initially. Then afterwards, what happened, as the bus is moving, the bus come to be in line with the taxi cab. Then it passes it. Still, the taxi cab is at rest. It is only when the bus is at this position, that is after 8 seconds, then the taxi cab begins to move. So it is asking us the time taken for the bus and the taxi cab to catch up. That is, the bus and the taxi cab will be in the same position. All right? Remember, if that is the situation, at this point, the cab was at rest, but the bus was moving. So it is only when the bus was at this position, that is after 8 seconds it has passed the cab, that is the moment the cab starts moving. So later on, the two bodies, that is the cab and the bus, meet up again. But this time both of them were moving. So this is for the bus and this is for the cab. One thing you need to understand is the bus was maintaining a uniform velocity, that is the velocity was constant, okay? So the velocity here will be 50 meters per second. The velocity here would be 50 meters per second. And even the final velocity also will be 50 meters per second, right? Because of it having a constant velocity, okay? So when a body is maintaining its velocity, it means that both the initial velocity and the final velocity are the same. But that is different for that of the cab because the cab was accelerating. So it means if a body is accelerating, we're expecting it to have a higher final velocity. We will get on to the solution, but let us just make this diagram to be well understood. we have the bus moving at 50 meters per second. We have the cab that is initially at rest. The bus passes the cab from this position, and it is only when the bus is at this position, that is 8 seconds later, then the cab begins to move. But the movement was in a form of acceleration. So let us explain this diagram again before we move on to solving the problem. We have a bus here that is initially moving at 50 meters per second, and we have the cab at this position that is initially at rest. The bus meet up with the cab that is at rest at this position. Still, the cab was at rest. So it is only when the bus was at this position, that is 8 seconds later, the cab begins to move, but the movement was in a form of acceleration. So the cab was accelerating, meaning it was successively increasing its speed. So it means its initial velocity is going to be lower than the final velocity. So the final velocity for the cab will be higher than its initial velocity. Unlike the case of the bus, which was moving at a constant speed. So because it is moving at a constant speed, its initial velocity and its final velocity will be the same. If we have to analyze the situation, what is important for us here is the situation here. This is what is important for us, okay? That is, for answering our first question, it asks us the time taken for the cab to catch up with the bus, okay? That is, how long does it take for the cab to catch up with the bus? Here, if you look at it, this is the first time they meet, but at that point, the cab was at rest, the bus was moving. This is the second time they meet again while both of them were moving. So it means from this point to this point, the distance will be the same. Okay? So they will travel equal distance for the cab to catch up with the bus. But you should always know that the bus will be 8 seconds ahead. Why? Because it is after 8 seconds that the cab starts to move. All right. So solution: let the time taken by the cab to catch up with the bus be t. So in that case, the time taken by the bus will be t plus 8 seconds, right? Because the bus is going to be 8 seconds ahead of the cab. So let's say distance traveled by the bus. The bus, we have to understand that it is moving at a constant speed. So if a body is moving at a constant speed, the formula for speed is equal to distance all over time. So therefore, distance is equal to speed times time. then distance is s. We can say s is equal to v, which is the speed, times t. So the distance for the bus, or the distance traveled by the bus, will be, the speed is what? 50 multiplied by what will be the time? Whatever time it takes, it is t plus 8, because it is 8 seconds ahead of the cab. So the distance traveled by the bus is equal to 50 into t plus 8. We can maintain this. All right. Now let's move on to establish an equation for the distance traveled by the cab. Distance traveled by the cab. What do we know about the cab? It was accelerating. Okay? It was accelerating. So if it is accelerating, what formula do we have to use? Formulas that incorporate acceleration in them. So we can use s is equal to ut plus half at squared, right? So the distance traveled by the cab is equal to, the initial velocity will be 0 since it started moving from rest, multiplied by the time is t, we've said that, plus half multiplied by the acceleration is 3, multiplied by the time, we don't know, it will be t squared. So the distance traveled by the cab is equal to 0 times t is 0, plus half of 3 is 1.5, so that is going to be 1.5 t squared. So what we know from the diagram is that for the cab to catch up with the bus, they have to travel equal distances, okay? So which means the distance traveled by the bus is equal to the distance traveled by the cab, all right? Distance traveled by the bus is equal to distance traveled by the cab. So what is the formula that we have for the bus, or the equation? It is 50 into t plus 8. This must be equal to 1.5 t squared. So if I expand this, I'm going to have 50t plus 50 multiplied by 8 gives 400. This is equal to 1.5 t squared. So this looks like a quadratic equation. So to equate it to 0, I can send this to the other side of the equation. In that case, I will have 1.5 t squared minus 50t minus 400 is equal to 0. This is a quadratic equation. So if I want, I can go and use this directly. Because I have 1.5 here, I want to make sure that I don't have a decimal here. So what can I do? If I multiply the whole equation by 2, then I would be able to eliminate the decimal. But still, if you want to use the equation as it is, you can. It is not a problem, okay? With the quadratic formula, you can use it as it is. But I want to make it simple for myself by multiplying the whole equation by 2. In that case, I can multiply everything by 2. So that will be 2 into 1.5 t squared minus 50t minus 400 is equal to 0. So 2 times 1.5 will be 3. That will be 3t squared minus 2 times 50 is 100. So that will be 100t minus 2 times 400 is 800 is equal to 0. So this is the quadratic equation. So quadratic equation is always in a form of ax squared plus bx plus c is equal to 0. If I should compare, a will be 3, b will be minus 100, c will be minus 800. Never forget the negative signs. So a is equal to 3, b is equal to minus 100, c is equal to minus 800, and x will therefore be equal to t. So if I want to find t, I will use the quadratic formula, which is t is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So substituting, t will be minus b is minus 100 plus or minus the square root of b is minus 100. So that will be squared minus 4 times a is 3, c is minus 800 all over 2 into a is 3. So t will be minus times minus will be positive, so that will be positive 100 plus or minus the square root of minus 100 squared is 10,000 minus 4 times 3 times minus 800 gives minus 9,600 all over 2 times 3 is 6. So t is equals to 100 plus or minus the square root of 10,000 minus minus will be positive, so that will be positive 9,600 all over 6. So t is equals to 100 plus or minus the square root of 10,000 plus 9,600 gives 19,600 all over 6. So t is equal to 100 plus or minus the square root of 19,600 is 140 all over 6. So t is equal to either 100 plus 140 over 6 or t is equals to 100 minus 140 over 6. So t is equal to 100 plus 140 is 240 divided by 6, or t is equal to 100 minus 140, which gives minus 40 over 6. So t is equal to 240 divided by 6 is 40, therefore t is equals to 40 seconds, or t is equal to minus 40 divided by 6 gives minus 6.67 seconds. So we know that time is never negative. Therefore, t is equals to 40 seconds. So this 40 seconds, it means is the time taken for the cab to catch up with the bus. Okay? So it will take 40 seconds before the cab can come in the same position with the bus after it starts accelerating. So we can now move on to answer question 2. Okay? So all this was for the solution of question 1. Question 2 asks us to calculate the distance the cab had traveled to catch up with the bus. The distance traveled by the cab is, so we can use this. This is going to be the distance traveled by the cab to catch up with the bus is 1.5 t squared, or we said that it's also going to be the same as the distance traveled by the bus. So we can use any of them. Either we use this or we use this. So let me use the distance traveled by the cab as 1.5 t squared. Question 2, the distance traveled by the cab is equal to 1.5 t squared. So that will be 1.5 times the time taken is 40, so that will be 40 squared. 1.5 times 40 squared is 2,400 meters. Moving on to the third question, it is asking us to calculate the final velocity of the cab when it catches up with the bus. So we are asked to calculate v. But before that, let's collect the data. The acceleration was 3 meters per second squared. The distance traveled is 2,400 meters. The time taken was 40 seconds, right? So we want to find the final velocity v. We can use v is equal to u plus at if we want. So that will be the u at initial velocity is 0 plus the acceleration is 3 times is 40. So 3 times 40 is going to be 120 meters per second. Or if we want alternatively, we can use v squared is equal to u squared plus 2as. In that case, the initial velocity is 0 squared plus 2 times acceleration is 3 multiplied by the distance traveled is 2,400. So that will be 0 squared is 0. 2 times 3 times 2,400 is 14,400. So v will be the square root of 14,400. V will be 120 meters per second. So any of them will work. Thank you very much for listening to this video. If this is the first time of visiting this channel, please subscribe, like, and share the video.